This video was brought to you by Indently.io, learning Python made simple. How's it going, everyone? In today's video, we're going to be covering 20 tips and tricks that you can use in everyday Python, starting with the first trick, which is a one-liner for swapping variables. So suppose you have two variables, one that contains text as a string and one that contains the integer value of 100. And suppose for whatever reason we want to assign B to A and A to B. Well, in Python, it's pretty simple. All we need to do is type in AB is equal to BA. So B will be assigned to A and A will be assigned to B. And just to make this more beautiful, I'm going to print before and after. And when we run this, what you should see is that before it was text 100 and after it's 100 text, because A contains 100 and B contains text now. And this is not limited to 2. You can even do it with 3 things. So we can also add something as more text. Or we'll just say Bob. Now we can say AB and C is going to equal CBA. And it's going to work the exact same way. Moving on to trick number 2, reversing iterables. Suppose you have two iterables, one which will be a list of integer and one which is just a simple string. In Python, if you ever want to reverse an iterable, you can either use the reversed method and flatten it, or you can type in your iterable name and use the syntax of : -1. And that will reverse everything inside of it. And we can do the same thing for a greeting. So that when we run this, you'll see that we will get the reverse of both of them. Tip number 3, string multiplication. In this example, I'm going to have a variable called shout of type string, and it's going to contain But anyway, typing out all these A's by hand can be quite annoying, especially if you want to be specific. So something else we can do is create something called shout2 type string. And here what we're going to do instead is type in A times 20. You can multiply strings in Python, which is really cool. And at the end, we're going to add H. So this time we're actually controlling how many A's we have in our shout, which means that when we print shout2, what we should get as an output is this string over here with 20 A's. But of course, you can also just print, let's say, Bob times 2, and you'll get Bob as an output because it works with any string. Tip number 4, one-line conditions. Imagine you have a number and you want to check whether this number is odd or even. Well, in general, you can create a simple if-else check, but let's try to put that all on one line. So here we'll type in result of type string is going to equal even if the condition is true, which is if the number modulus operator, I said modulus operator, 2 is equal to 0. Else it's going to be odd. And this is all it took to check whether it was odd or even. So now we can just print that result and we will find out whether 10 is odd or even. And you don't even have to assign this to a result. You can literally just place it directly in your print statement and it will work the exact same way. Tip number 5, concatenating strings or joining strings. And for this example, we're going to have a big variable called emails, which contains 3 emails. And what we want to do is combine these emails into a nicely formatted string. Because right now, if we were to print this, we can say print the f string of emails, and we can place in those emails. But when we return this, we're going to get this list object back, which isn't really nice for the users. So what we can do instead is use some quotation marks, use a space and a comma, and type in join. And this will insert this string in between all of them. So now we can type in, we want to join these emails. And before we run this, I'll just switch this around. But now if we were to run this, you'll see that we will have it nicely formatted. We'll have a comma, and then the end. And this can be literally any string you want. You can even add 3 dashes and they will go between these strings. .join just makes it easy to combine elements from an iterable together. Up next, we have tip number 6. And for this example, I'm going to be using a dictionary of type string to string, which means we have a string key and a string value for each element. And when you are working with dictionaries, it's quite common that you're going to try to access something that doesn't exist, maybe ABC. But obviously that raises a key error. So what's a good way to get around this if you don't want to raise an exception? Well, something different that we can actually do is use dot notation and use the get method for the key that we're going to specify. So here, if we want to get the age, for example, what we're going to get as a return instead is none, because age does not exist in our dictionary. And that's exactly what get does. It tries to get the value, and if it doesn't exist, it returns none. And alternatively, you can even add a default value directly after the value that you're trying to get. So this will be the default value, and I'm just going to call it default, which means if it cannot find age inside the dictionary, it's going to return default, or whatever you decide to put inside here. That can even be an integer if you want. You can add 999 or -1 or whatever you want to return as a default. Otherwise, if you enter name, you will get the name back. Tip number 6, set default. A very powerful method we have with dictionaries, which is very similar to get. So for this example, we're going to have some scores, which is a dictionary of type string to integer. And Bob is obviously winning. But what we want to do next is create a variable called Bob's score of type integer, and we want to try to get the score from Bob. So we'll type in scores.get, or not this time. This time we're going to type in set default. And here we're going to type in Bob. And in case Bob doesn't exist, we're going to set the default to 0, which means that if this user does not exist, this dictionary is going to have a new value called Bob with the default set to 0, so the next time we can actually keep track of that user. And here we'll type in Bob's score. But obviously, since Bob exists already, we're going to get Bob's score back. But what we can do now is copy and paste this below and change Bob's score to James' score. And we're going to try to grab the value for James. And then we can print James' score, and at the bottom we're going to print all of the scores. Now what you should notice is that when we try to run this, James' score is going to return 0 by default because James does not exist in the dictionary. And in addition to returning 0, it also created a new entry in our dictionary with James, who has a score of 0. So from this point forward, we can actually keep track of whatever score James might get. Tip number 8, counters. In programming, there are going to be moments that you're going to want to keep track of how many elements exist in a certain iterable. And we have two options at this point. We can either create our own custom functionality to try to find out how many elements exist in an iterable, or we can go for the easy approach, which is importing the counter from collections. And for demonstration purposes, I'm going to create a list called letters, which is going to contain a bunch of recurring letters. Then right below that, I'm going to create a counter of type counter, and all I'm going to do is wrap the letters in this counter. And what that means is that we can get a bunch of statistics back from this counter, such as if we were to print the counter.total, this will count how many elements are inside this list in total. So here we have 8 letters. But something even more useful is the most common method, because this will return which one of these are the most common. And at this point, we have 3 A's, 2 B's, and 2 C's. So the counter object just makes it much easier to count what elements are inside our iterables. And optionally, you can also specify how many you want to get back for the most common. Here we can say only to return the top 3, and that's exactly what it will do. Tip number 9, enumerate. By this point, if you've been programming in Python, you probably already know what enumerate does. It allows you to enumerate any iterable. So here we can type in for I and letter in enumerate letters. We will print the enumeration and the letter. So what that should give us back are the letters enumerated, starting at 0. If you want this to start at 1, you have the option to add 1 to I, and the enumeration will start at 1. But something that's nicer that a lot of devs don't know about is that you can directly set a start. And you can set that to 1, so the enumeration will begin with 1. And you'll get the exact same output. And the benefit to this approach is that you can enter any number you want without having to do any crazy math. So if you want to start this at -1000, that's fine. You can do that, and it will start from -1000. Up next, we have trick number 10, dictionary merging. So to get started with this example, I'm going to create 2 dictionaries of string to integer. And here we have A1, B2, and for B we have C3 and D4. And what we want to do is combine both of these dictionaries. Well, the easiest way to do it is to type in A, pipeline, B, and that's going to combine both of the dictionaries into a new one. Otherwise, if you just want to update one dictionary, you can type in A, pipeline equals B. So you can actually perform that in-place operation, and the next time you print A, you're going to get the exact same output. Tip number 11, underscore formatting. If you ever have some sort of big number, not bug number, but big number, you probably have encountered the problem of trying to keep track of the zeros. Here I wanted to create the number of 1 million, but obviously I messed up because I'm blind and I have a hard time tracking how many zeros are here. So one thing you can do in Python is place an underscore as a 1000 separator, or it doesn't have to be a 1000 separator because you can place it anywhere you want. So depending on the country you live in, you can place the underscore anywhere you want. These will be ignored by Python as soon as you run your program. As you can see, if we were to print the big number, we would get no underscores in the output. This is only to help us as developers keep track of what we're doing so we don't make that silly mistake. But there's something else we can do. So pretend we have another big number, and here we're just going to hard code it, but you might have gotten this value from somewhere else, and you want to be able to read this much more easily in the console. Well, what we can do is print the f string of this big number and use colon underscore. And this will place the underscore between the thousands so that when we run this, we will see exactly what this number is without having to use a pair of glasses or a microscope, which just makes it much more convenient. And of course, you can also do this with a comma. But unfortunately, those are the only two separators that we have in Python when it comes to f-string formatting. Up next, we have tip number 12. And for this example, I'm going to create a class called multiplier. And in the initializer, we're just going to grab a value and assign it to the instance. And the only reason we're doing this is because I want to show you that you can make a class directly callable. And to do so, all you need to use is the call dunder method. And here, instead of args and keyword arguments, we're going to replace that with other value of type integer. And this will return an integer. Then we can return self.value times other value. And what's cool about this is that we can create a sort of currying with our classes, which means that we can type in something such as double of type multiplier, and that will equal a multiplier of 2. And if we ever want to call that, all we need to do is type in double with the number that we want to multiply, because the class is now directly callable as soon as we instantiate it. And when we run it, you'll see we will get back 20 as an output. But you're not required to do all of this. You can also just type in multiplier directly as an instance and add another pair of parentheses after that. Because once again, this sets up the class and this actually calls it. Although I wouldn't recommend this approach because it looks quite confusing. I would definitely recommend you set it up in a way that's much more readable, such as creating an instance called double. But otherwise, it works exactly the same way. Tip number 13, method chaining. For this example, I'm going to create a class called person. And this person is going to take a name and an age. And it's also going to contain two methods that directly modify the instance. So the first one's going to be called modify name, which takes a new name and returns self. So all we're going to do here that's different than usual is return self. And I'll show you why we're going to do this in just a moment. And right below that, we're going to have one that's called modify age, which will also return self. But now that we have these two crazy methods that return self, we can move on to the actual demonstration of what this does. So at the bottom, I'm going to create a variable called Bob of type person, and that's going to equal a person who's obviously named Jeff. I'm joking, it's going to be Bob, with the age of 29. And now with Bob, we can actually modify that information using those methods. So we can modify the age, which we can set to 10 for whatever reason. Bob is now younger, and we can chain this with another method, such as modify name. And this can be set to Bob, or it's already Bob. I'm kind of crazy today, so we'll set it to James. But as you can see, we can chain these methods indefinitely. And now the next time we print out the f string of bob.name, and bob.age, we should get the new values, such as James and 10. Moving on to tip number 14, which is just a trick I like to use all the time when I'm printing elements from an iterable to the console. So in this example, we're going to have a list of type string called foods. And what I want to do is print all of these foods to the console. But what I'm going to do is first unpack them so that I can use the special arguments that come with the print statement, such as the separator. Between each element, I'm going to want to use a comma and a space. And at the end of this, I want to add a full stop. The default of end is a new line, so I'd recommend you use that as well, in addition to using the full stop, so that the next time you print, it will start on a new line. But now when we run this, you'll see that our elements will be printed to the console in a nice format. But of course, you can change this to whatever you want. You can also add a dash in between, and it will look like this. Tip number 15, representation. At this point, if you've ever worked with a class, you'll know how annoying it is to actually print the instance of any class. And you might be asking, what am I talking about? Why is it annoying? Well, let's create an instance of this person and print this person. What you'll notice in the console is that we will get this very useful output regarding that person, that it's a person at this memory address. And I hope you can hear the sarcasm in my voice, because this tells us literally nothing other than this is just a person object. Now, unless you're a robot, this information isn't that useful. So something else we can do instead, which can be very useful for a developer, is to add the dunder representation method. And this will return a string. And you can literally return whatever string you want, but I would recommend you return something that's readable to the developer. So by returning this kind of string, we're telling the developer that it's still a person object, but that it contains this information, so that the next time we actually print this person object, we get some useful information back, something that we can actually understand. Tip number 16, a quick way to grab the first element and the last element of any iterable. For this example, we're going to have a list of people, which will contain the strings of Bob, James, George, Fred, Luigi, and Sophia. So what we're going to do is first type in first, and then I'm going to use an asterisk and an underscore, and then type in last. And that's going to equal the people. Now what this does is first grab the first element, and then by adding an asterisk and a variable name, we are unpacking everything in the middle. This doesn't have to be an underscore. Underscore is just the convention for throwaway values. This can also be middle if you want, but we're going to leave it at underscore. And then finally, we're going to get the last person. And with that being done, we can type in first and last. And what you should notice in the console is that we will get back both Bob and Sophia. The only thing to note with this approach is that you should have at least 2 elements for this to actually work. And in case you're curious about what's inside the middle, you can also print underscore. And what you'll notice is that it contains the rest of the elements. It literally absorbed them so that we could grab the first and last element from our list. Moving on to tip number 17, which is my favorite debugging trick of all time. So for this example, we're going to have a name and an age. And for whatever reason, we're going to want to print these variables to the console with their variable names. So here we can add the f string, add some curly braces, and we're going to type in name equals. And we're going to do the same thing for age. And what you're going to notice is that we're going to get both the variable name and the actual value or result of this expression. And this is really cool because you can literally put whatever you want inside here. You can also add the length of, let's say, name, or you can do 1 plus 2, and it's going to evaluate it there with the actual expression. So it's just a very cool, quick way to debug your code. Tip number 18, rounding. Sometimes in your programs, you're going to have some very weird numbers with some very weird decimals. And depending on what you're doing, you're not always going to care about precision because it will hurt readability. Such as if someone is 12 years old, you wouldn't really care for the rest of that information that shows that they are 12 point blah 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 years old. But anyway, let's move on to the round method. which allows us to round a number to any amount of decimal places. For example, we can round it to 2 decimal places, and we will get our number rounded to these 2 decimal places. If you decide to exclude the precision, it's going to convert it into an integer. Otherwise, what's very interesting about the round method is that you can also go backwards, so you can actually start rounding the whole number. So by providing -1, you'll see that it's going to round it to the 10. Otherwise, with -3, it's going to round it to the nearest 1000. So I just thought it was really cool that you can also go backwards with rounding. Tip number 19, string replacement. So here we're going to have a sentence that reads as, the tired red fox on the red farm ate a bored red pig. And what we want to do is print the sentence dot replace red with XXX, just to show you where it was replaced. And if we were to run this, you'll notice that it replaced every single occurrence of red, even if it was inside tired or inside bored. And I did that intentionally to show you how you can easily get around that. Well, in any case, if we were to duplicate this, a very easy way to get around this is to add a space in front of the variable, or not the variable, but the string you're actually searching for. And of course, you need to replace it with something such as blue, but that should also contain a space. So the next time you actually replace that string, you'll get the correct translation. The tired blue fox on the blue farm ate a bored blue pig. Otherwise, if we were to leave that space in, you'll see that this sentence will not make any sense at all. The blue fox on the blue farm ate a blue pig. And it's cool because there's Bob. And finally, we have the last tip of the day, which is being able to provide a key for max and min in Python. And to demonstrate that, I'm going to import this list of string, which will contain all of these names. And I might actually just break this so you can see all of them. But it will contain Timothy, Bob, James, Zebra, Amanda, Anna, and Luigi. And right now, if we were to print the max of names or the min of names, we should get back the default implementation, which will return the max and the min of the ASCII values. So here we'll get Zebra as the max and Amanda as the min. But what if we have a different implementation that we want to use to calculate the max and the min? For example, what if I want to say that the max is whatever name contains the most A's and the min is the opposite of that? Well, just to show you right now where we're standing with the names, I'm going to create this for loop, which first will print the name and the name.lower.count of A. So we can see how many A's each name contains. So next, if we were to run this, we'll see that Bob and Timothy contain 0, while James and Zebra contains 1, and Amanda contains 3, and then Anna and Luigi 2 and 0. So what we want is Amanda to come back as the max value. Well, let's define a key that does just that. So here we're going to print the max of names, and we're going to define the key, which is going to equal this lambda expression, lambda x dot lower dot count of A. So this is going to return an integer, which is going to be used to calculate the max, because it's going to use this comparison. Now, if we were to run this, what we should get at the bottom is Amanda. And to make this more obvious that that's the max, we'll add the string of max. So as you can see, max is Amanda. Otherwise, if we were to change this to the min, we're going to get Timothy, because that was the first value that contains 0. It's not going to do this alphabetically anymore. It's just going to grab the first value that it found, which contains 0, since both Bob, Timothy, and Luigi contain 0. But let's change this back to max, because I realized I also forgot to change this to minimum when running the program, because something else you can do is also compare them by the length, just by entering the length method. And this is without the parentheses, because it's going to call this on every single element and return the one that has the longest length. So now if we were to run this, we would get Timothy, because Timothy has the longest length. And we can actually change this to length so we can see the length of all the names to verify that. So here we get the length of all the names. Bob has the shortest name and Timothy has the longest, which means obviously if we were to duplicate this, type in min, and change this to min as well, we should get Bob as an output. All I wanted to mention is that we can define our own custom key in case you want some sort of custom implementation for both the max and min methods. So yeah, those were 20 tips and tricks that you can use in everyday Python. Do let me know in the comment section down below what you thought about these, whether you have some tips and tricks that you would like to share. But otherwise, as always, thanks for watching and I'll see you in the next video.